Hi everyone, welcome back to Lulumath. This video is on finding an equation of a real-life quadratic relation, and this is the second video. This video is taking into consideration the possibility that the background knowledge does not include how to solve quadratic equations. And in fact, the only background information that you need is you need to know how to find the equations of quadratic relations in vertex or factored form. And there are videos on both of these on the Lulumath website as well as the Lulumath YouTube channel. So we use vertex form if given the vertex in another point, and we use factored form if given the roots in another point. So in this question, we're told that the St. Louis Arch is 192 meters wide and 192 meters tall. We want to find an equation to represent the height y and the width x of the arch in meters. So the first thing we want to do is define our variables. But the nice thing is this question already defines it for us. We're told that the width is x, and it's in meters, and we're told that the height is y. And just a reminder that this is the independent variable and this is the dependent variable. Let's draw a sketch of what's happening here to get a better understanding of how to find the equation of this situation. So again, we're told that the x, or the independent variable, is the width, and that the height is the y, or the dependent variable. We also know that the arch is 192 meters wide, and we know it's 192 meters tall. It doesn't say in the problem, but it is also symmetrical. So we know that it reaches this 192 meter height directly in the middle of the arch. So in the middle would be half of 192, so this is 96 meters. And we know that it's on the ground at 0 meters and 192 meters for width. So here is a rough sketch of what we have here. Now these points that we have here are our roots. So we know that our roots are at 0 and at 192. And this point right here is our vertex, it's our maximum, and we know it's at 96, 192. Now, because we're given the vertex and the roots, we can use either vertex form or factored form. But for the purposes of this video, we're going to use factored form. So just a reminder that factored form is y equals a times x minus r times x minus s, where r and s are our roots. So you can choose which root to be r and which root to be s. It's totally up to you. I'm going to use r as 0 and s as 192. So let's go ahead and fill in that information. So this is going to say y equals a times x minus, and I will write down the r as 0, and then x minus, and instead of s, I will use 192. But if you remember, when we talked about this in the factored form video, x minus 0 is simply x. So this is just y equals a times x minus 192. Now I can substitute a point in. So the point that I will substitute in is the vertex, because that's the only other point that I have that's not a root. So we know that the x value of our vertex is 96 and the y value of our vertex is 192. So we will replace the x's with this 96 we talked about, and we will replace the y with the 192. So this will say 192 equals a times x, which is 96, times another x minus 192. So I will do 96 minus 192. Well, we know that 96 minus 192 is negative 96. And then I will copy the rest of the equation down. So 192 equals a times 96 times negative 96. Now, to make my life a little bit easier, I'm going to divide everything through by 96, okay? And this 96 cancels out, and 192 divided by 96 is simply 2. So 2 equals, and then I have a times negative 96 left over. So I get 2 equals negative 96a. Divide both sides by negative 96, and I end up getting 2 over negative 96 is equal to a. Well, if a equals 2 over negative 96, we can simplify that by dividing both the numerator and the denominator by 2, and I get negative 1 over 48. So this is what a is. So I can replace this a right here with negative 1 over 48. So my new equation is going to say y equals negative 1 over 48 multiplied by x minus 192. And this right here is my equation. I could distribute this through, but I don't have to do that. Okay, now we're told that Cameron was 5 meters from the base of one side of the arch and looked up. How high above the ground was the arch? So essentially what's happening is we know that he is 5 meters away from one side of the arch, and he looks up, and we want to know how high up this is right here. So we will use our equation to help us determine this value. And since this is our x value, we're going to plug in 5 for x. And when we evaluate 5 minus 192, we get negative 187. Multiply that by 5, multiply that by negative 1 over 48. So this is technically over 1 over 1. So when I multiply this through here, I would get negative 1 times 5 times negative 187, which is 935. And then in the denominator, it's 48 over 1 over 1. So my answer here would be 935 over 48. But I want to know approximately how much that's going to be. And when I type that into my calculator, I'll get approximately 19.5 meters. So therefore, the arch was 19.5 meters above the ground when Cameron was 5 meters from the base of one side of the arch. So now we want to know, how much farther does Cameron need to walk for the arch to be the same height above the ground as when he was 5 meters from the base? We know that this is approximately 19.5 meters, and if I were to go all the way across, I want to know how far he needs to walk from here to here. So what is this distance right here? Now remember that our parabolas are symmetrical, so we know that it is from this point to this point right here, from the beginning of the arch to this 5 meters right here, this is 5 meters. So we also know from here to here also has to be 5 meters. So that means that this point right here is 192 minus 5 meters, or 187 meters. So that means that from this point, from this 5 meters here, all the way to where it is 19.5 meters again, it's a distance between 5 meters to 187 meters. So to figure that out, I would simply do 187 minus 5, which would end up giving me 182 meters. So therefore, Cameron needs to walk an additional 182 meters to reach the same height on the other side of the arch. All right, awesome. So let's go ahead and use Desmos to verify all of our answers to this problem here. So we got as our equation y equals negative 1 over 48 multiplied by x multiplied by the quantity x minus 192. And we can't see our full parabola right now because our zoom is not proper. So we know that our arch is 192 meters wide. I'm going to have my width go out to 200 because that goes past the 192 that I need. And we also know that it goes to a maximum height of 192. So I'm going to have my height go up to 200 so I can see that as well. Now, if you look and see, we can see it goes from 0 to 192, which is exactly what we need. And we can also see that it has a maximum height of 192 at a width of 96 meters. So this looks really good. This looks really promising. Now, we also need to determine what value of y we're going to get when x is 5. So I'm going to do negative 1 over 48 times 5 times 5 minus 192. So here we can see that y is equal to approximately 19.5. Okay, and then if you look on the other side here, this occurs at 187 meters for our width. And since we're trying to go from 5 to 187, that is a distance of 182 meters. And that's it for this video. If you have any questions, let us know in the comments below or at lulumath.com, where you can also find blank or completed notes for this video. If you found this video to be useful, please make sure to subscribe and share with others. Thank you, and we'll catch you next time. Bye.